Hi everyone, this is our last video from the Bloom's Taxonomy course, and we're going to be putting it into practice, which is obviously the final goal of this course that we've all been studying, is putting Bloom's Taxonomy into practice in our classrooms. So I hope that by the time we've made it here, you're really excited to get some Bloom's Taxonomy into your classroom. So here is a recap of Bloom's Taxonomy. Knowledge and comprehension are considered lower level thinking skills. Application and analysis are the mid-level thinking skills, and synthesis and evaluation are the higher order thinking skills. And this was in a previous presentation, but let's just review it. When should we use each level of Bloom's taxonomy? Knowledge and comprehension are the lower levels. So we should use knowledge when we want our students to possess basic information. We should write objectives at the comprehension level when we want students to demonstrate their understanding. When we want students to use their learned information in a new situation, that's application. And when we want our students to show us that they can see the parts of a relationship, that's analysis. If we are having our students create original work, we're writing objectives at the synthesis level. And if we want our students to grade, make a judgment, defend it based on either internal or external criteria, then we would write an objective at the evaluation level. And so here is a recap of all of the Bloom's taxonomy action verbs. We've seen those in the past as well. And this is a review of what a curriculum map is, because as instructors, I mean, the goal of this whole course is to improve our instruction, to make us better teachers. And so my challenge to you is to go back to your curriculum map if you have one. If you don't, maybe it's time to start thinking about one. But go back to your curriculum map, which is, as you recall, the curriculum is everything that you teach your students throughout the whole course. And then you break that curriculum up into units, and each unit has goals. And within each unit, you have lessons, and each lesson has goals, and each lesson has instructional objectives. And so we've been operating down here at the lesson level. But my challenge to you, now that your completion is right on the edge here, I would challenge you to go back to your curriculum map and look to see where you can make some very specific instructional objectives using Bloom's taxonomy. And remember, an instructional objective is measurable. So where can you make some clear-cut instructional objectives that you can measure? So how do we write an instructional objective? Let's just review. We pick the Bloom's taxonomy level that we're going to be asking our students to perform. We begin with the student will, that's what the TSW, BAT, be able to. So the student will be able to. Then we write our action verb and our topic, and then we give us an accuracy level. And remember, we don't always aim for 100%. If it's first time doing something that's really challenging, the student will be able to compute stoichiometry problems at 50% accuracy. Stoichiometry is challenging for a lot of students. That's a chemistry term. I know not everyone in here is a chemist, and that's fine. But if it's something that's challenging, you might not want your students to be at the 100% accuracy level on day one, because they just might not be there yet. If you're studying something for multiple days, maybe you start at 50% accuracy, then 75% accuracy, then 100% accuracy. And so this is what I challenge you to do now that you are almost a graduate of this course. Pick a topic in your area that you know students struggle with, and then pick 6 subtopics within that area. And then write an instructional objective for each of those levels, one at each level of Bloom's taxonomy. And to really push yourself, write an assessment that you could use for each one of those objectives. So challenge accepted. I'm going to show you mine. I wrote one for balancing equations. So in chemistry, students really struggle with balancing equations. It's a challenging topic because it requires them to visualize. It requires them to use some computation. It requires them to keep track of what's on the reactants and the products, and they really can make themselves tied up in knots if they don't work on it a lot. So I spend a lot of time working on balancing equations with my students. So to begin at the knowledge level, my instructional objective, and I don't have any accuracy levels on these. I should, but this is just for an example. The student will be able to identify the key symbols in a chemical equation. Because for me as a teacher, the students need to know what those symbols stand for in order to write a balanced equation. Just like if you're not a chemist listening to this presentation, you would say, what's a balanced equation? If you don't know the symbols, you can't write an equation, right? So here would be my assessment for that. When given an equation, the students must write what each symbol means. So what does each chemical equation mean? What do the states of matter mean? What does the arrow mean? They need to write what those symbols mean. Just what is the symbol? At the comprehension level, the student will be able to translate a chemical equation into his or her own words. So I give an equation, H2 plus O2 makes H2O. Now, granted, that's not balanced, but we haven't balanced it yet at this level, right? We're just giving them an equation and then they rewrite it using their own words. They would say, okay, hydrogen gas plus oxygen gas makes water. That's unbalanced because we haven't actually balanced the equation yet. We're just working on translation at this point. Now we can actually balance it when we get to application. The student will be able to apply the rules of balancing equation to an unbalanced equation. So going back to my H2 plus O2 makes H2O, that's an unbalanced equation. So when given an unbalanced equation, students must balance it. They have to use those rules of balancing equation to apply it, to balance that equation. All right, at the analysis level, the student will be able to classify chemical equations by their type. So if I give my students a series of equations, they need to classify them by types. Are they synthesis reactions? Are they decomposition reactions? Are they single displacement, double displacement, redox, whatever. They need to be able to classify them by type. The student will be able to design, write, and balance the chemical equation for a hypothetical reaction. Now, this can be really difficult because introductory level topics, students don't fully understand chemistry yet. So for me as the instructor, I would really have to be careful because my students might design a hypothetical reaction that doesn't exist. I can't really be too picky in my grading of this if this is an introductory level skill, because I might look at this and say, yes, that's a possible reaction, but thermodynamics says that reaction is never going to happen. I can't get too picky about the chemistry of it, but I would just look to see, can my students design an experiment or design a chemical reaction? Can they design it, write it, balance it, and it's completely novel? And I, as the instructor, would just have to ignore whether or not that reaction would actually take place in the real world. And then for evaluation, the student will be able to grade chemical equations for accuracy and precision. So I would put on the teacher hat on them. I would say, when given fictitious students' equations, students must grade them for accuracy. So all of these are assessments, right, that would measure how well my students have met these instructional objectives, because a good instructional objective is measurable, which means there should be an assessment that goes along with it. And then you as the instructor can go back and reevaluate and say, oh, they really don't get this. I need to spend more time at the knowledge level before I move on to the comprehension level. Or maybe they blew it out of the water and you say, great, they know this, I can move on. So assessments are very valuable, not only to the learner because they give the learner feedback on where they're making their mistakes, but it also gives us valuable feedback as instructors because it tells us where we can improve our teaching. So that's where we're going to end. And congratulations, you have completed the Bloom's Taxonomy course. I really hope you've enjoyed this. And I know I've enjoyed preparing all this and working with you. And so if you ever have questions or want to reach out to me, please feel free to. And I hope you have a great day. Bye.